Hello, Charger family. This is Mrs. Boyd. Welcome to Mrs. Boyd's Math Room. Today, we're going to talk about relations. It's going to be amazing. All right, so we're going to take, let's learn what a relation is. Relation is a set of ordered pairs. Ordered. Holy cow, that was harder than it should have been. Pairs, and that's in the form XY. Here is our set of ordered pairs right here. And we're going to make those look like lots of different things. So first, let's put them in a table. We're going to always put X on the left and Y on the right. Let's list our points, X, Y, in pairs like this. So we have 4, 3, -2, -1, 2, -4. That's a 4 promise. And 0, -4. Mapping, I'm gonna have to fix that 1, -4. It's really gonna bother me. Okay, so mapping, we're gonna write all of the different values of X in this left oval. So let's do that. Only one 4, only one -2, only one 2, only one 0. Okay. On the second oval, we're going to write all the different values of Y. So we've got only one 3, only one -1, and 2 -4s. So we just write that once. Now we're going to take arrows and make pairs with the values that they go with. So let's look at the table. 4 goes with 3, so we're going to match those up with an arrow. -2 goes with -1, arrows together. 2 with -4, arrow. 0 with -4, arrow. All right, looks a little bit like that. Now we could graph these points. Is another way to show how they're related. So 4, 3 is the first point. -2, -1, 2, -4, and 0, -4. Oh, that's not right. Now, I want you to notice that I'm not going to connect these with a line. These are not a line. These are 4 separate and distinct points that are not related except for that they're all together in this relation. The domain, I'm going to leave this up here like that. The domain of these points are all of the X values listed. So fancy brackets. And then we list all the X values, 4, -2, 2, and 0. Fancy brackets. You can essentially take them straight out of the mapping from the left. Range are the possible Y values. Fancy brackets. Look at the mapping on the right. 3, -1, -4 apparently, and -1. For the domain and range, we do not repeat. Okay, so there's 2 -4s in our table. We don't repeat them in the map. We don't repeat them on the range. Okay. Independent variable, that's the domain. And in this case, it's X. Dependent variable is the range. And in this case, it's Y. Let's do another, just like this. A table. You're going to have to draw your own here. Put X and Y at the top. And then list our points side by side. 2, 3, 2, -1, 0, 3, -1, -3. A map. We need some ovals. It's going to be X on the left and Y on the right. Let's list all our points. 2 is listed twice. We just put it once. 0, -1. And then on the right, 3, -1, -3. Those are the only separate values. 2 goes with 3, so we put an arrow. 2 also goes with -1. 0 goes with 3. -1 goes with -3. Now we graph these points. 2, 3, 2, -1, 0, 3, and -1, -3. Again, those do not get connected with a line because they are not a line. They're just 4 random points. The domain, fancy brackets, everything in our X map, 2, 0, -1. Range, everything in our Y map, 3, -1, -3. All right, and if you can do that, you've got the gist of it. Flip your paper on over. We're going to talk about graphs and relations and what that means. The graph below on the top left here represents the height of a baseball after it is hit. The independent variable is always X. In this case, it's time. The dependent variable is always Y. In this case, it's height. Now let's talk about what this graph looks like. So here is a point where the ball is hit. So the ball is hit at, let's just call it A height. It's not on the ground, right? Because the ground would be down here. And we can't tell the value of this height, just at A height. And then, so let's look as time goes on. As time goes on, the height rises. So as time passes, the ball gets to a maximum height. Okay, the maximum height is going to be right here, the highest point on this curve. Well, then what happens? We get to this maximum height, and then it goes down. So the height starts to decrease. Until the ball hits the ground. Okay, and here is where it hits the ground when height is 0. All right, so pretty clear what we're doing. We're just describing what this graph says. Next one, the graph represents the speed of a bus as it travels to school. Let's do the easy part here. Independent variable is X, that's time. Dependent variable is Y, 2 E's, and that's speed. Whew. All right, so when we start here at time 0, speed is 0. So we start and the bus is at a standstill. And then time passes and it gets faster and accelerates. So the speed, sorry, my handwriting and spelling are struggling today. A-C-C-E-L-E-R, accelerates. And so if acceleration is where the line is getting steeper, it's going up. When the speed is steady, it's not accelerating. So the bus travels at a constant speed. And then its speed decreases That means, and then it slows until it stops. So when X is, or when Y is 0 again, the speed is 0 and the bus is stopped. Just a few more here. This graph represents the price of the stock over time. Well, that means independent variable is X, and that's time. Dependent variable is Y, and that's price. So let's look at this. If when Y is positive, that means the price is positive. So a stock has a positive price. It increases, decreases, and then increases. Holy mackerel. Increases, decreases, and then it increases, but it's even higher than it was before. So it increases higher than before, and then it decreases again. Not a lot of specifics we can say with this one because, again, we're just given variables and no specific numbers. The graph represents the balance of a savings account. Well, independent variable is time. Dependent is balance in the account. All right, so when time is 0, when we start looking at this account, it does have a balance. So there is money in an account which is increasing so it increases and then it stays the same. And then stays the same for a while. Let's look at it after it stays the same. It's going to increase a little bit. So that means more money is added. And then eventually, when we get down here, all of the money is taken out or withdrawn. Okay, so the important thing I want you to be able to see here is what happens, what does it mean in the context of the problem when the graph increases, stays the same, decreases, and what do the intercepts tell us? So the intercept here tells us there was money, added more, stayed the same, added more, took it all out. Stock price started at a level, went up, went down, went up, went down. Kind of how we expect stocks to do. Up here again, the ball was hit not on the ground at a height, went up to a maximum height, and then fell down to the ground. And then this bus moving started not moving at all, accelerated, stayed the same, decelerated, and came to a stop again. Okay, so the important parts here to be able to describe what's happening on the graph and understand what happens in the relation to what the problem is telling you. I hope this makes some sense. If not, you know how to find me, and I hope to see you very soon.